Hello, hello. I've decided to check in for you guys on YouTube. I've split, or rather I've cloned the code in two, and since I didn't really have the time to do any streaming or explaining, but had a few moments of spare time for coding, I decided to, um, as you can see, uh, work on the project. So yeah, uh, we have camera controls, input controls, uh, some lighting and some materials. Um, so yeah, we really got to a nice place. I also implemented an OBJ loader that I wrote for another program, and I fine-tuned it a bit. I still think that there will be several optimizations, but yeah, it works for now. It imports the normals, and it creates the required amount of vertices and normals for those. So yeah, now we can use lighting. The next thing I wanted to do was to create an algorithm that allows us to mark different objects, being it bounding boxes or um, uh, cameras, or in this instance lights, so that you can show it on the screen. You could do decals, but that is somewhat more complicated, and I would still like to be able to draw boxes. Um, from a point. Um, we could do it on the GPU side, but yeah, I've chosen not to. Um, yeah, so that's the plan. Um, yeah, the next step would be perhaps to do some collision checking. That would allow us to actually create a world and um, interact with it, since we can just load up some models from Blender and then use those as a test environment. Mm, yeah, I also need to do local transforms, but maybe that is easier to do when we do instancing. So yeah, instancing and collision checking is fairly high on the list. Let's see. Yeah, I haven't disabled input polling when the window is not in focus, but yeah, doesn't matter. Anyway, we need to do the algorithm that expands a point in space into um, into a, a set of vertices. Yeah, and it's strictly not math. It's a combination of math and nah, it's not really math. It's so easy. I'm not even gonna optimize it. So yeah, in the renderer, I would like to expand on our line pipeline state and feed the objects into that. So yeah. Maybe I should do a header file under the general render stuff, since it's probably API agnostic anyway. Yeah. Let's do a header file called render utils. And let's create a namespace for it. We would like the data structures, and thereby we get the math. Yeah, we do. So this is a function that is supposed to take, what format do we work in? We do work in float threes. Yeah, vectors are for math with intrinsics. This is just for calculating vertices. Alright. And our data structures, vertex line. Yeah, it uses floats as well, so it will return a, let's see, I think a vector of a vertex line. Build box from point, and we take in a gfloat 3 reference position. We would like to be able to scale it let's do a float scale. And let's do a color. We could take an I value. Yeah, it doesn't matter too much. Let's start with that. We might add components. So we want to have a point in 3D space XYZ, and we would like 8 points. For now, this will have a identity matrix as. Or will it have? Maybe I really should. Okay, next I have to do translation matrices for objects. Because we have to translate the objects in 3D space whenever we build them. We will start at small, but eventually we will build structures that can hold several objects and manage them in memory. So, one for each corner of a box. So, we would like let's see, let's take our. So we have the z-axis, we have the y-axis, and we have the. So for 0, we would like one corner. Yeah. Vertex line. Let's see. Let's build vertex line vector, and then 4 equals 0 and less than 8. We want to create. I'm just thinking. That maybe we don't want to iterate over it. Maybe we just want to create them manually. Yeah, maybe it's easier just to create them manually. Vertex line, temp vex. So we start with where we get position.x. And we subtract 1.f times scale. Then we have position y, and we subtract 1.f dot scale, and we have position c, and we do the same. So that's one corner. And set the color to whatever color. And then first corner, where we minus all axes with, and then instead of moving well, we could move it and reassign it. Isn't that faster than copying? I don't know, doesn't really matter much. We could move. It will give us less text if we just copy it. There we go. Then we should be able to do the second corner. Let's see, -1 times and -1, -1, just so we know. Then we would like one where the x-axis is +1 and the rest is -1, -1. Therefore we plus this one. And this should mean that our color doesn't get invalidated, and therefore we do not need to re-specify it. If we moved it, it would get invalidated. So yeah, maybe this is at least more readable, I think. Let's see, next corner. How should we do this so that we get every option? Then +1 here. Let's try that. And then where we have that one, so that is half. Let's see. Plus. Let's do one where, let's see, did I do this correctly? So yeah, that one is plus. That one is plus, minus, plus. Alright. This one is going to be minus and then +1. So this one is going to be minus, this is going to be plus. That's 5. We would like one where the last one is a +1. Alright, now we simply start with all negative, then first one is positive, second one is positive, third one is positive, then the first two is positive. Then let's create one where the last two are positive. Let's see, how many was that? 1, 2, 3, 4, 5, 6, 7. Yeah, it's actually just 7 points. Because if we draw it in order, it will be 8. So let's just use our renderer here as an example. The z-axis is negative, the x-axis is positive. Let's see, which are we looking down the angle? I think we are. Whoops. Camera controller. Let's see, our camera. Yeah. We are looking down the negative z-axis. Yeah. So we would like for the positive, oh yeah, and y is negative also when going upwards, right? Yeah, so this is negative y. So our first point here is positive x, positive y. Let's see, yeah, positive x, positive y, and let's do a positive c, positive x, positive y, positive c. So this is our first point. Let's do color here. So positive c, positive y, positive x. Then we would like positive c, positive y, negative x. Positive c, positive y, negative x. There we go. And then we would like a point that is negative z, but positive, or rather negative z, negative x, but positive y. Yeah, maybe I should do an index buffer for this, because I will be needing more points. Yeah, but negative z, negative x, positive y. There we go. Then we would like a positive x and y, but negative z. There we go. And that is supposed to be the bottom half. So our indices is supposed to go 0 to 1, 1 to 2, 2 to 3. So 0 to 1, 1 to 2, 2 to 3, 3 to 0. Then we would like a point that is negative y, but positive x and c. Negative y, positive x and c. missed that one. Yeah, I actually didn't create that one. So positive X, positive C, negative Y, there we go. And then we would like to draw from 0 to 4, right? So this is 0, 1, 2, 3, 4. And then we will go to negative X, negative Y, and positive C. So let's do from 4th to 5th, but also from 5th to 1st, meaning that we will draw from here to here. All right. Then we want a negative X, negative, all three negative. Did we just negative, negative, positive C? Yeah. So we just shift this one down here and say we would like for 5 to 6, which is actually our 7th. And then we would also like 0, 1, 2 from our 6th to number 2. Then our last point will be here, which is negative C, positive X, negative Y. So that is actually the last point here. And we would like to draw from 6 to 7, but also from 7 down to 0, 3, 7 to 3, but also from 1, 2, 3, 4, 0, 1, 2, 3, 4, but 7 to 4. There we go. So these are our vertices. Let's see. Let's create a vector. Just for now, we won't be using it since we will return our vector here. But let's see. Int unsigned int. Then we will push back 0, 1. Then we will do 1, 2. Then we will do 2, 3. 3, 0. Then 0, 4. then 4, 5, then 5, 1 actually, then 5, 6, 5, 6, then whoops, then 6 to 2, then 6 to 7, then R7 to 3, and R7 and 4. Alright. Let's just split this off into another helper method that will just spit out the vertices, or rather indices. Unsigned int, get build box from point indices. There we go. No, we'll need to clutter that, or clutter something with that. All right. Let's check it out in our renderer. Load models, then coordinate lines, then we do some boxes, wire box. Let's see. Maybe we want a separate buffer for it. We're not. It's mostly for debugging purposes anyway. So yeah. Pipelines. Yeah, maybe. Yeah, for now we will. I don't actually think I use that anymore. I don't use that anymore, do I? Except for releasing it. Yeah. Might as well just remove it then. Yeah. So for now, system structures are going to be here, and then boxes for debug. Let's see, we would like box box view vertex indices box buffer box buffer view. There we go. Let's create some of those. Let's see, what did our helper function return? Vertex line, box vertices equal to utils, build box from point. Let's say we would like a point of 3 to pass in a point 3 and then -2 on the, whoops, I meant to swap these, and then a color which is float 4. Let's do red. And then a scale of 2. Reference. Are we allowed to do a G float 3 constructor? If we allow it to take our values, we can both pass in. Yeah, I think this will still work, but let's see. Box indices. There we go. Oops. Let's see, we would like to initialize this. With the size of vertex line times the size of this one. Let's see. Box. Debug boxes. All right. Let's create a view to it. And then upload it. Cue the upload. go. Then we would like to upload, or rather, unsigned int. Let's move that down to here so that we know what we're doing. And then indices. And then we will create a index buffer view into this one. And instead we do box indices to get size. Be right back. Alright. And then let's upload this. And copy this. And that should be it. And then we upload, let's see. Let's see if we check out NVIDIA Insight. "2,000 frames per second is pretty fine. Let's see, debug boxes, indices. Maybe I just forgot to rename some value here. There we go. let's see. But we have nothing in there. So our indice doesn't get queued correctly. It's because we don't specify the right resource. Let's see, and we do not create the correct descriptors as well. There were a lot of different things to change. Let's see, so it does get arranged, it does get uploaded, and therefore we should be able to ask our engine to draw it now. Let's see. It's not doing the load. It's not. It's supposed to be here. So afterwards, draw debug box. Let's see. We still have the same vertex buffer, but we want to set our index buffer to our index buffer view. Oh, it's not a vertex buffer, of course, it's index buffer. There we go. And then we do draw. Let's see. Base vertex location. The last one is supposed to be 6, I think. Oh well, not 36, of course. What did we expect? We expected, let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 24. Let's see. Now we do not get any errors, at least. But we do not draw our box. And why is that? Let's see. Maybe it just stays in the center underneath the box, because I don't think that it gets translated anywhere. Let's just test that. Or rather, no, actually it's another index vertex buffer as well. I'm not reusing that old one, therefore we're not supposed to do like that. We need to change it to our box. Let's see, num views. Yeah, there we go. There we go. Even though it doesn't get translated. Yeah, so now we draw both. The scale is pretty big. Okay, now we can Mm. Draw our position of our camera, or rather of our light source. We will only do a scale of 1. So it's here. Shining down. Maybe I would rather like a, well, white would be a great color for a light. And let's do a bit of a smaller scale. So, yeah. Now we have some debugging utilities. Yeah. Great stuff, great stuff. Eventually you do some decals or whatever. You could also do different symbols. It doesn't have to be a box. You could, for instance, do a pyramid instead if you wanted a light source. Yeah, but for now we will do fine by that. Yeah. That is it for now, at least on YouTube. Let me know somewhere if you ever get to this point during the YouTube series if you want me to show the intermediate steps between the previous installment and this installment, since there are a lot of different ones. Yeah, I'm not really gonna do video editing, so I can do coding and explanations on stream, but I would rather not be obliged, or rather forced to edit the videos afterwards. So yeah, but I don't think that there are a lot of people following this series. So yeah, for now I'll just do this specific build and continue on improving that one. And then if people ever get curious, I'll sort of take you through the steps. Yeah. But see you in the next one.